So our next speaker, next talk is from Maarten Coonen and from Maastricht University in the Netherlands. The title is Fair Data Management and Discoverability. It's not a typo. Thank you to the 4 people who asked me that.
Thank you for the introduction. Thank you for being here as a presenter. Today I will be talking about a new tool that we have connected to iRODS over the past year, which will allow us to discover metadata better. But before I'm going to talk about that, a little bit of background information about our department for those of you who don't know us. We are residing in the University Medical Center of Maastricht. It's the southernmost city in the Netherlands. We are a service organization and we target at the university hospital and the life sciences faculty. We act as a data broker. We focus on data management, not on data science. And we work with a lot of decentral data stewards from the research departments. Sorry, you can hear me better now, thank you. We work with a lot of decentral data stewards from the research departments who are the domain experts and can help us building a generic infrastructure. And if you have visited the UGM last year, you might remember the talk by Paul van Schaik, one of my colleagues, who spoke about our architecture and iRODS and all the applications that we have connected to it. So I'm not going over that. What I will be mentioning in this presentation is a little bit of history. So we started in 2014 with our project and started our developments in 2015. And now, well, in 2016 we had the first production release. And now, as you can also see in the graph on the lower right, you see that we are encountering a huge data explosion over the past few months. So we are now at about 35 terabytes of data with, let me see, about 170 users. One of our missions is to make data fair available across domains, across research disciplines. And we want to share data in a regulated fashion between organizations. And we want to hold data sets that are both human and machine readable. And if you are talking about machine readability, the FAIR principles come up in mind. And what I try to illustrate in this table is on the leftmost column, the actions that we take in our infrastructure, and then to which of the 15 FAIR principles these map. So, for instance, each data set in our iRODS environment is accompanied with a persistent identifier. We use ontologies to enrich our metadata. We use the EBI ontology lookup service for that, so we have a web form in which users can annotate the data that they're uploading and automatically assign ontology identifiers to that. We register the metadata and the data in iRODS, and we make that searchable in the Discover system, the topic of this presentation. We have some landing pages that are HTTP resolvable that provide a public version of the metadata. And we even have the metadata accessible even when the data is deleted in iRODS or is protected by authorization layers. So I think that we are only missing 2 of the FAIR principles in our infrastructure, and that is that we have to think about data licensing and extend our metadata so that it also includes provenance information and traceability of the research workflow that a researcher has done with the data. So I have talked about human findability, but what is also very interesting is how can we make metadata and data machine readable, machine interoperable. And for that you need information from ontology systems. So for those of you who don't know what ontologies are, I have created this slide, or actually my colleague Paul van Schaik created this slide. So imagine that we have 2 organisms, a human and a mouse. And for us as humans, it's very logical to know that both a human and a mouse are part of the mammal group of organisms. But a computer doesn't know. So here is where ontologies come into action. And in ontologies, relationships between concepts are defined. So if you add knowledge from ontologies on top of these three concepts, you will find out, or a computer system can find out, that a human is connected to mammals via the order of primates, and that a mouse is connected to the mammals by the order of rodents. So if you are now wanting to search, create search queries on mammals, the computer system can deduce that it should look for humans and mammals and all of the other humans, mouse, and all of the other relevant organisms. So if you add all the information that is residing in ontologies together and combine that with all the public data sources that are already available, then you will end up with a huge, massive, open linked data cloud. And what you see in this visualization is all the open public data sets from different domains. So for instance, in purple there is, I think that's the life sciences domain, and we also have social sciences. So this is a massive cloud that we as humans are not able to traverse. So we need tooling for that will help us with that. Well, we at Data Hub Maastricht found a partner in this, in the software application OntoForce Discover. So what we did is that in OntoForce Discover, we have a lot of publicly available data sources on a federated instance of Discover, and we hooked up our iRODS system to Discover. And in that way, it becomes possible to simultaneously search across data sets and different systems. And you can do this for iRODS, but you can also do this for a lot of other systems. So you can also make ETL tooling available that will make your research databases searchable through Discover, or your medical records, or whatever data repository that you are using. So, what is OntoForce Discover? Well, OntoForce is a Belgium-based company that also has offices in the US, and it's a semantic search application on linked data. They have a very user-friendly interface with nice visualizations. And what I find most important and most exciting about this tooling is that an end user doesn't have to know linked data expertise and doesn't have to know how to write Sparkle queries himself. He can just use the dynamic filters and widgets in the tool to construct his search query and traverse the linked open data cloud. And what's also very cool is that you can hook up your private data that is on premises, for instance in iRODS, to this system. And a user can just simultaneously search everything. So how have we hooked up iRODS into this Discover system? Well, on the top left you see our iRODS system. It has some metadata in it, in XML files or in AVUs. And we use the iRODS REST API to access that data and transfer those data into a staging environment. And then by a series of ETL scripts, transformation scripts, we create TTL turtle. TTL stands for turtle, so RDF formatted files. And RDF is one of the main data formats in the linked data world. So those TTL files, those RDF files, are then imported in Discover's triple store, and then it can be made searchable, or the end user can search through it using the interface. So you can search in Discover on metadata that we have extracted on iRODS. And now you will ask yourself, well, how does he get the iRODS the data that is stored in iRODS itself? So what's also part of the metadata is a link out with an epic persistent identifier. And an epic persistent identifier is a form of a URI. And if you assign a URI to a data set in iRODS, it also becomes retrievable using linked data technologies. So that's what we do. So we have a link out from the Discover system using this URI, which forwards the user to a landing page. And on this landing page, he can then access the data in iRODS either through the iRODS cloud browser or through the DevRODS interface. So how does our ETL workflow look like? Well, As I mentioned on my previous slide, we have two types of metadata. One is stored in XML files and the other one is in iRODS AVUs. So if we want to transfer or transform these iRODS AVUs into Turtle format, you will see that we have a iRODS rule that exports this data into a JSON file, and then that JSON file is parsed by a Python ETL script, and then you will end up with the data structure that is on the lower right of this slide. The same procedure, well, a similar procedure is used for the XML files. So we use the iRODS REST API to simply download the file into the staging environment, and you will see the XML file in the middle. You will see some information about the project to which this data set belongs, and a short description and a title. And in the TTL box, you will then see that this information is a bit exploded into triples, but you will see that the same information is there. And this is the linked data format. Well, I think I have shown you enough about the theory. So let's do something more exciting and see how this works in practice and how an end user will approach this system. So I have prepared two screencasts. The first one will show a user that is primarily searching for iRODS data, for an iRODS collection that he has uploaded himself. The second screencast will show a user that is not primarily searching for iRODS data, but is just searching for information on a gene in publicly available sources, and then will end up at a linked data source that we have in iRODS containing information about this gene. So let me switch applications. Okay, you can see that. So this is the main interface of Discover. In the boxes, you will see all the categories of which linked data is available. Did it start? Yes. So if I now go to data sources, you will see that there are data sources located on our premises data store, and there are also public data sources. If I start a new discovery, and I go to a Data Hub project, which is the way in which we organize our iRODS data, we can see that there are about 9 users that are assigned to this project. Those users have access to the data stored in iRODS. If you now go back to the project and then click on the collection type, we will see that there are 4 data sets located in this project. We can filter on a lot of things like upload date or tissue or publication. But in this case, we are interested in data sets of humans. So we select that in the filter. And here we are at an overview of this project, of this collection. So you see it's residing in project 2. If we click on the DevRODS link, you will end up at the WebDev connection, and you can download the data. And this is the XML file that I was talking of before. Okay, so that showed how a user can directly search for iRODS data. The second screencast will show a use case of a user that is just interested in finding gene information. So again, the main screen, we can search on free text, CGI58 in this case. We click on the gene type in order to filter for genes. And now we get a lot of information from public data sources like NCBI gene about this gene. If we now filter on the human version of this gene, we can see that it has a synonym in the name of CGI58. We can see for which diseases this gene is a target. Now we switch to the type of disease. We get a lot of listing of diseases related to this gene or defects in this gene. If we now would like to find out more about this gene, a logical next step would maybe be to search for publications from Pubmed that are associated with this gene. We find a list of 522 publications. We can scroll to that. And on the top, you will now see that I have expanded all the categories containing data associated or related, linked, in fact, to this gene. So you will see a lot of categories. You see journals, diseases, chemicals, organisms, proteins, but you also see a collection. And this collection is actual data in IRODS, the collection that we saw in the previous screencast. So if we now click on that collection again, use the WebDev link, we end up with the data residing in IRODS. We can download it if we are authorized. And that's it. That's linked data and IRODS. So let me give me 1 minute. I would like to thank all the members of my team who have made this possible. I would also like to thank the people working at Ontoforce company who have worked with us together in a strategic partnership to make this possible. On your tables you will find these flyers. So if you are interested, feel free to take them home, speak to your colleagues about it, and if there are any questions, I'm happy to answer them now or in the breaks.
Any questions about all that? Somebody's got a question. There's one.
So just to clarify, when your users are uploading data sets, do they have to use metadata terms from predefined vocabularies, or is it free text and then you somehow associate their terms with what is in the service? And yeah.
Yeah, so the question is about how people enter metadata and then convert it into links. Yeah, exactly. So we have metadata forms for that in the Drupal web portal. We use autocomplete mechanisms to the ontology lookup service, so a user can just type free text in a box, and then he will get suggestions of terms that could be relevant, and then he can select one. And at the back end, we then store the identifier of this term. So the user will just search on free text, but the system will store the URI.
I saw another hand earlier. Maybe. All right. Well, thank you very much.
Okay, you're welcome.